Okay, we're going to continue 10-4 here. So vector functions and their derivatives, it's actually easier than it sounds. There's a couple pieces up here. We've got r of t. There's the x piece here, the y piece here. To find the derivative, you literally just take the derivative of this piece and then the derivative of that piece. Okay, so if you need to take the derivative of a vector, you just take the derivative of each part. So let's just start with find the derivative. So bold your r. That's the hardest part of this. We have r prime of t. What would be the I portion of this? No, just the r. It's saying that it's a vector. So what's the derivative of the I portion? 3t squared. So 3t squared, and you bold the I, plus, what do I have to do for the j portion? Product rule. So I will write it out, but you guys can do your writing it quick if you want to. Okay, so first times derivative of the second plus the second times the derivative of the first, and then that's got a j in the back. You guys know how to write it in the other form with just the brackets, right? So you could do that if you wanted to. You can clean this up, just pull the negative out front. Or you could pull an e to the negative t out altogether if you really wanted to. So any questions on derivative? I mean, if you do, just ask the person next to you and they'll tell you how to do it. Just take the derivative of each piece. Okay, the unit tangent vector, you're just using this here. Do you guys remember how I said a vector has both direction and magnitude? Yeah, this is the magnitude. How could you? Okay, this is magnitude. So it's written as like the absolute value of the vector. That means what is the length of that vector. So do you see how this is really Pythagorean theorem? You do your first piece squared plus your second piece squared. So that would be your distance to the right squared plus your distance up squared, and then you square root it to find what your hypotenuse is. So if you drew it, you could just do whatever this piece is squared, whatever this piece is squared, and then take the square root. So that's what that is. Okay, it's the distance from here to here. What are you saying? Yeah, so this is like your x portion and this is your y portion, but it's like if we drew this, let's say it's 2, 7. That means you're starting anywhere. You're going to the right 2 and you're going up 7. So if you're trying to find the length from here to here, wouldn't you do 2 squared plus 7 squared and then do the square root of it? So that's all this is here. So do you have to really memorize that formula? Not so much, as long as you realize you're finding the length of it. You should be able to find the length of it. Okay, so that's the magnitude. So if you notice when we're trying to find the unit tangent vector, you're going to find the magnitude of r prime of t in the denominator, and then you're going to find what r prime of t is for the numerator. So let me erase this stuff here. Okay, so unit tangent vector, let's start by writing, we're talking about when t is 0, so let's find r prime at 0. So it's not like we're going to get an equation here because we're actually plugging into it. Now notice the numerator here is going to end up being a vector. Okay, so you have your first piece. What do I get in my first piece if I plug in 0? 0. And the back piece is 1. Okay, so that's what goes in the numerator when I'm finding, I'm going to call it t of t. And it ends up being a vector, so that's why it's bolded here. So you've got the 0, comma 1 on top. And then on the bottom, you have to do the magnitude of that, right? So you're literally just taking this squared plus this squared and square rooting it. I'll write it out for this one, but obviously you could do that one in your head. So you get 0, 1 over 1? Everyone okay with that? So if this wasn't 1, let's say it was 2, you'd just divide both of these pieces by 2, and that would be your final. So ours is just 0, 1. Now if I wrote that in terms of I and j, what would that equal? Just 0i plus 1j, so just j. I don't know how the answer key will write stuff, so you might see something like that. Questions on that? I would say most of the BC curriculum, especially the first couple units, like nothing about it is super complex. It's just hard to remember because everything's so scattered. You know, like we do vectors for a couple little sections here, and we did L'Hopital's and we did Newton's method and all that stuff. Like it's all just kind of separate stuff. When we get to the end, we do like 2 sections, a full chapter of kind of complex stuff, but at least it's all similar to each other. So this first stuff, I'd say it's not super hard, but you do have to kind of keep on top of it to make sure you got all your formulas done. Okay, the next page here, for the curve, find the derivative and sketch the position vector and the tangent vector. So go ahead and start by finding the derivative. I'll give you a minute there. Okay, so for this curve, we're finding r prime of t. So even if you're not sure how to do the whole thing, get the easy parts out of the way. So r prime of t, you're just taking the derivative. So did you guys get 1 over 2 squared of t for the I portion? And then 1 minus, I should say, 1 for the j portion. And then you want to find what r of 1 is and what r prime of 1 is. So let's do the r prime because we just did that piece. If we plug 1 into that, what would we get? One half and then negative 1. Yep. Okay, and then finding what r of 1 is, you're just plugging back up into the original piece up there. So that's going to give us 1, 1. Now, in your homework, it's going to ask you to do this. It would not ask you to do this, I don't think, on the AP test, so I wouldn't stress too much about it. But what you're going to do now, it says for this, find the derivative and sketch the position vector and the tangent vector at 1. So we are going to sketch this first. So start at 0, 0. And let's make 1 go out like 4 spots here so we can actually see it. So let's put 1 here and 1 up here. Okay, so if we're starting at 0, 0 and we do the vector 1, 1, you go to the right 1, up 1. And that's where your vector would stop, correct? Everyone okay with that? Then start at that spot and do the second piece, the derivative. So we're going to the right how much? 1 half, so that's 2 blocks here, and we're going down 1. Okay, so it's going to end here and sketch in that one. Oops, what is that? Okay, now if you sketched in that curve, I'm not going to get super technical because we've done our curve sketching already. But if we sketched in that curve would start, let me see here, if I plug in t is 0. If I plug in 0, do you guys see how I get 0, 2? So that's where this graph would start, is up at 0, 2. When I plugged in 1, it was here. If I plug in 2, I would get square root of 2 comma 0. So square root of 2, 0 is approximately there. So this graph is kind of this curve shape. So let me amaze you with my smartboard and, write on it. So do you see how the original vector just gets to that equation or gets to that graph? And then what does that tangent, or what does the derivative tangent vector do? It draws a tangent line at that spot, okay? So, I mean, it makes sense. It's not something you're going to have to memorize for your AP test, but that will be in your homework. So that should happen if you do it correctly in your homework, where it goes to the curve and then it draws a tangent at that spot, okay? Amazing. Okay, next page you can probably even do on your own. Integrals of vector functions, just do the integral of each piece. Make sense? So I'm going to let you guys try it. We'll see if anyone gets the right answer here. And I'm going to start working out pieces up here, writing little pieces as you guys go. But I just wrote equals. I didn't even write one, so I suppose you would say this equals, but I don't know if I'd go with big R. I think vectors are actually all written lowercase, just bolded, so I would say no, but yeah, how do you get rid of that? Yeah, I guess you just got to stick with it. Any questions? Is it going pretty well? Is that looking right so far? And then just plug in the top, subtract, plug in the bottom. Okay, so this is actually 0, right? Sine of 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so this just turns into 2i. And cosine of 0 is 1, so it's just j, or 1j. Questions on it? Or you could write it as, 2 comma 1, right? I know, super exciting stuff, so. Oh, did I? Yeah, because you're subtracting a negative, or no? Am I good? Because you plug in the top, and then you subtract, and you... Are we good? I'll explain it in a minute. Questions on that? Yeah, two negatives make positive, no big deal. Cool, so there's your homework. It's actually decently straightforward. The only thing you might get caught up on, again, is really this here, because it's like kind of unclear as to what you have to do. Just refer to that page and you should be good to go.